Hello students, hopefully by this time you've done your lesson 10 practice problems, which are on page 219 in your book, and so we'll go over those real quick and we'll start to discuss them. So this first one, problem 1 that you have, it says Andre bought a new bag of cat food. He opened it to feed his cat. The graph shows how many ounces were left in the bag on the days after he bought it. So you say at day 0, he starts at 56 ounces of cat food. And then over the span of, it looks like about maybe 33 days or so, he got down to 0. So he has an empty cat food bag. Okay? So it says how many ounces of food. So this is ounces of cat food. That's what we're looking for. How many ounces of cat food were in the bag 12 days after Andre bought it? So 12 days. So you go here to 12. And you follow this up, and it looks like it's about somewhere between 32 and 40, about halfway. So that's probably about 36 ounces, I think. Let's follow this line across. It's about halfway between those two, which is 36. So you should have about 36 ounces here. How many days did it take for the bag to contain 16 ounces of food? So if we go here, we know that we have 16 ounces of food. We want to find the number of days. We can start on the ounces of food this time, follow to the right. Looks like about right here, come down, and it looks like it's 24 days. 24 days into this, he's got 16 ounces of food left. How much did the bag weigh before it was opened? Well, before it was opened, right, at time 0, looks like 56 ounces of food. And how many days did it take for the bag to be empty? Well, it's empty when it has 0 ounces of food, so you follow it across. It looks like it's about 33, maybe 34 days or so. So, about there. And then look at the next one, problem 2. A Little League baseball team is ordering hats. Okay, the graph shows the relationship between the total cost in dollars and the number of hats. So here's the hats that are ordered. Here's the total cost. And I'm going to guess that's, let's see, probably in dollars, I'm going to guess. They don't already tell us. They should put units on these sometimes. All right. This is nice because they put ounces and days. So you have units. Here they have total cost, and I'm going to assume it's in dollars. The graph shows a relationship between the cost in dollars. Dollars should be listed here. And the number of hats ordered. What does the slope of the graph tell us for this situation? Well, what does this graph tell us? It's a positive slope. It's going up when we go left to right. So as the number of hats ordered increases, so does the dollar amount cost. Well, this kind of makes sense. You get more hats, you pay more money. All right. If you got 0 hats, then that is your setup cost. Looks like it's maybe about $35 or so, about there. You have to look a little closer on that one. We don't have an equation just yet, so we'll have to look at that one. All right. So what does the slope of the graph tell us in this situation? Well, let's see. Does it tell us that there's a fixed cost of approximately $35? No, it doesn't tell us that. Right? There's no fixed. That would mean that the slope is like a slope of 35. So no. It tells us the amount of total cost increases for each additional hat ordered. That looks pretty good. That looks like a really good. It tells us that when 9 hats are ordered, the total cost is approximately $160. Let's see, 9 hats. We follow up 9. All right, does it tell? Yeah. When he tells us that when 9 hats are ordered, the total approximate cost is $160. So 9 hats ordered, and you go up to here and follow it across. It looks like $160. So that looks like C is a correct answer as well. And let's go on to D. It tells us that when the number of hats ordered increases by 10, the total cost increases by 10, the total cost increases by approximately $175. Well, let's see. If we went from 0 to 10, it went from about $35 up to about $175. It didn't increase by that. You got to remember this total increase from about 175 versus 35 went up about 140. So if they were to say 140, I could buy that, but no, that's not true. So the only answer you should be getting here is B and C as being true. Number 3, a group of hikers is progressing steadily along an uphill trail. The graph shows their elevation or height above sea level. So here's your elevation. Oh good, they put in units this time, thanks. And over here, the distance along the trail is miles, so you can kind of think of this as going up a hill. All right, as you go down the trail, you're going to be going up to a higher elevation, so you're going uphill. What's the slope of the graph? Well, let's see. What's the slope? Remember, the slope is the rise divided by the run, if you want to think of it that way. Let's get out my little graph here, my little piece of paper, and we'll figure this out. All right. So let's see what it says. Problem number 3. And let me get to the right page in my book. All right. So what's it telling us? Well, if we look at this, what's the slope? You got to remember this is the slope. The slope symbol is m. You have rise divided by the run. All right. So if you look at this, it went, if you want to say from between 0 and 2 miles, so we're going to draw a little triangle right here, okay? So what was the rise? Well, it went up about from 500 to 1,000, so it went up about 500 right here. And that's a positive 500, okay? And then along here we have 2 miles that it went, so that's the run, it's a positive direction. So that's divided by 2. So 500 divided by 2 is 250 feet per mile. That is your slope. What does the slope tell us about the situation? Well, it tells us how the elevation increases with every mile. But it's in its constant increase. It's almost like you have a perfectly straight, sloping hill that you're working with there. So that's what it tells us. Write an equation that expresses the relationship between the hiker's distance from start to finish. Very simple. We figured out the slope. It's right there. And we know the y-intercept is right there. It's 0, 500. So there's the 0, 500. The 500 we're going to use right there. And the slope is 250 feet per mile times the number of miles. So there's your equation that you should have gotten at this point. Okay. Does the equation of y minus 250x equals 500? Well, if I went and took this thing and swapped it over to this side, subtracted 250x from each side, it would disappear over here and reappear over here. So yes, it's the exact. And yes, subtract 250x to the other side. So that's basically what happened there. Number 4. Let me go and get this all situated. The kindergarten teacher bought $21 worth of stickers and cardstock for the class. The sticker cost $1.50 a sheet. So here are your stickers. And cardstock costs $3.50 per pack. So there is your cardstock. The equation represents the relationship between the sheets of stickers, S, packs of cardstock, C, and the dollar amount, which is $21. Alright, and spend on these supplies. So explain how we can graph this situation. Well, if I go and put in 0, 6, right, I get no stickers and all cardstock. Then I get 6 cardstocks. 6 times 3.5 is 21, so there's a point. And we go down here, and we have 14 times 1.5. That's 21 plus 0, right? When you put the C value in there, that's what I'll get. So 14 and 0. Okay? And so if you notice, you got a straight line between here, and there's a little point in the middle of it that looks like it could work as well. That's about halfway between the two. Okay? And here's some math to kind of show you what we're doing here. We use the y-intercepts and the x-intercept to kind of figure this out, and we add another little point on there. All right? Let's see. What do the vertical and horizontal intercepts 0, 6 and 14, 0 mean in this situation? Well, 0, 6 means you buy 0 stickers and 6 sheets of cardstock. 14, 0 means you buy 14 stickers and no cardstock. That's what it physically means. All right. Now down to some physics. In physics, the equation PV equals nRT, which is called the ideal gas law. So perhaps sometime in the future when you take chemistry, you'll learn all about the ideal gas law. It used to approximate the behavior of any gases under different conditions. P, V, and T represent pressure, volume, and temperature N represents the number of moles in the gas, and R is a constant. It's just there, it's just a constant. And we've done all kinds of experiments to determine exactly what that constant is. All right, which equation is equivalent is solve for T. So if we take this thing and we say PV equals nRT, and you want to solve for temperature right there, you divide by its coefficient. Well, that's the unknown. The coefficient of the unknown is the N and the R. So you divide both sides by N and R, and so T equals PV divided by NR. Well, that's the one that it looks most like. All right, that's B. All right, so that's your answer on number 5. On to number 6. To raise funds for uniforms and travel expenses, the soccer team is holding a car wash in a part of town with a lot of cars and trucks. The team spent $90 on supplies like sponges and soap. They plan on charging $5 per car, $20 per truck, and their goal is $460. They want to raise $460. Okay, so this is a little bit different. They had to spend some money in the very beginning and then wash the cars and trucks, and their goal is to raise $460. So there's a couple ways you can do this. You can do it like we did here. We actually put it into the equation. $10 per car plus $20 per truck. That's all the things that are going to be adding money to this. But you had to get rid of that $90 expenditure so that you walk away at the end of the day with $460. That's the goal here. Okay. So what we're talking about here is you'd actually have to go and raise, if you add 90 and 460, you'd have to actually make, through washing cars and trucks alone, you'd have to make $550 to make back the $90 and hopefully raise $460. So this first one here or this second one is going to be an appropriate equation. Okay? And so we're going to need to go through here and see how many we'll have to do to go and meet that. So I'm going to use this one just because it's more simplified. Okay? So if I have 4 trucks, all right? So if I have 4 trucks, that's 4 times 20, so that's 80. Subtract 80 from each side, and you'll get $470. So you'll need 47 cars if you're going to only wash 4 trucks. Well, if you have 15 trucks, well, 20 times 15, that's 300. 550 minus 300, now you're talking 250, so you'll need 25 cars. For 21 trucks, so 20 times 21 is going to be 420. Let's see. 20 times 21, 0, 2, 4, $420. Subtract that, that's 110, or excuse me, $130 left over. So 10 times 13 will give you that. So there's your answer for 13. And then 27 trucks. Well, 27 times 20, there's a 0. 14, carry the 1, 540. All right, so you just have to wash 1 car for that. And of course, if it's just T trucks, you have this number right here. You'll notice that you have a 10, a 20, and a 550. Each one ends in 0. You can reduce this, right? If you have 10C plus 20T equals 550, you can divide everything by 10, and this turns out 1 car plus 2 trucks equals 55, right? And so if you want to just put in the T, all right, in other words, you want to solve this equation for C, you just subtract 2T from each side, and you'll have C all by itself. 55 minus 2T, right? And so that's where they get this equation here from. All right, number 7. In the Middle Ages, people often used grains, scruples, and drams to measure the weights of different medicines. 120 grains are equivalent to 6 scruples. 6 scruples are equivalent to 2 drams. How many drams are equivalent to 300 grains? Okay, So I'm going to set this up and I'll be right back because I have a little bit different way of solving this than what they have here, but neither way is wrong. It's just a different way to go and view the problem, and we'll go through each. Alright, so I've basically written down the information they gave us. They said 120 grains is equal to 6 scruples, and 6 scruples is equal to 2 drams. Alright, so I've got this right here. And I've set these up as kind of fractions. Now, the way to think of this is I'm actually representing the number 1 here. The value on top and the value down below is the same value. It's the same amount of stuff. If I gave you 120 grains of something or 6 scruples of something, it would be the same amount. Same thing over here. If I gave you 6 scruples, it's the same as having 2 drams. Right? It's the same thing. It's the number 1. So if you look at this thing, I can actually go and cancel the 6's, and I can cancel the scruples, and what am I left with? Well, I'm left with 120 grains divided by 2 drams. Okay? So this tells me the number of grains per dram or number of drams per grain. And if you notice, 120 and 2, they have a common factor of 2. So this is the same thing as saying 60 grains is equal to 1 dram. Right? So now what they're asking you for, and later on in this problem, they're asking you for how many drams are there are equivalent to 300 grains. So you start out with 300 grains. And see, these are each what's known as conversion factors. Even that's a conversion factor. That links grains to scruples, scruples to drams, and grains to drams. Okay? So now if you look at this and you look at this, you want to get rid of grains. So I'm going to put the units on opposite sides of the fraction bar. And I'm going to put drams up here, which is what I'm ultimately looking for. And it's 60 grains for every 1 dram. Okay, the grains cancel. And you look at 60 and 300. Well, 60 is a factor for 300. So we can cancel that and just make that a 5. So what do you got? You got a 5, you got a 1, and you got a drams. That's the only thing you got left. So what do you got? 300 grains. It turns out to be 5 drams. Okay. And so now what they do is they kind of set this up a little bit with equal signs, and that's fine. I mean, 120 grains is equal to 6 scruples. 6 scruples is equal to 2 drams. Since they're both equal to 6 drams, you could say that 120 grams is equal to 2 drams. And then they said, well, okay, in this case, they multiply both sides by 5. You go from 60 to 300. You go from 5 times 1 up to 5. So they say that 5 drams is equal to 300. So whichever way you like to think about it is okay. Right? I like my conversion factor stuff a little bit better. That's the way I'm used to doing these problems. On to number 8. Again, it's another review. Explain why the equation 2 times the quantity 3x minus 5 is equal to 6x plus 8 has no solutions. Okay, so let's go through this thing. Let's go and simply distribute the first off. So 2 times 3x is 6x. 2 times 5 is 10, so I'm going to keep the subtraction down with it. And then over here I got 6x plus 8. Right? Now, I don't want to divide both sides by x because that would be wrong, because x might very well be 0. Right? Never divide by a variable if you can at all help it. Alright, so I'm going to subtract 6 from each side, and I get up with negative 10 equals a positive 8. Well, negative 10 can't be equal to positive 8, so this will never happen, so there are no solutions. So what they did here mathematically is okay. You can add and subtract variables. You can't divide by them. Okay? So, yeah, this will never happen. Consider this equation right here. If we solve the equation for n, which equation will result? Alright, so let's just take this thing. What did they do? They said, okay, I got 3a plus 0.1n equals 123. Okay, I'm solving for n. So first I got to use addition subtraction, get it all by itself. So I'm going to go move it over to here. by subtracting 3a. So 0.1n equals 123 minus 3a. And then I divide everything by 0.1. And what do you get? Well, I get to get an n here. And then 123 divided by 1/10, or 0.01, that increases it to 1230. I still got my subtract, and 3 divided by 1/10 is equal to 30a. All right? So which one does that look like? Well, it looks exactly like this one right here. Charlie. Charlie's your answer. On to number 10. Diego's buying shrimp and rice to make dinner. Shrimp costs $6.20 a pound, and rice costs $1.50 a pound. Diego spent $10.55 buying shrimp and rice, and they give you a relationship right here with this equation. So there's your pounds of shrimp, and there's your pounds of rice, and that's the total amount spent. Right? Write an equation that makes it easy to find the number of pounds of rice. So I want to find the number of pounds of rice. I got to solve for R. If we know the pounds of shrimp being purchased, so we know S, we want to isolate that. Find the number of pounds of rice. We want to solve for R. So we want to take this equation and solve for R. So what do? Well, we write it out. I want to solve for the R, so I want to get it all by itself. First thing I do is addition and subtraction to get it all by itself. So I subtract 620S from both sides, and I get 125R equals 1055 minus 620S, right? And then I want just 1R, not 1.25R, so I divide by 1.25 and divide everything by 1.25. And this is the answer that I get. Okay, R equals a negative 4.96S plus 0.8. And that's it for the practice problems. So we'll start next on lesson number 11.